Hello, and welcome to my video describing Kirchhoff's voltage law and its relationship to alternating currents. Kirchhoff's voltage law is one of the most useful tools for analysing electrical circuits. It states that the algebraic sum of all voltages around a closed loop in a circuit must equal zero. If Kirchhoff's voltage rule was applied to this resistive circuit as an example, we would find that the sum of all voltage drops across the two resistors must equal the supply voltage. If we were to give numeric values to this circuit, say if the supply voltage was 10 volts and R1 had a voltage drop of 7 volts, then we would measure a voltage drop of 3 volts across R1. Let's now apply Kirchhoff's voltage law to an AC circuit. In this example, KVL will be used to find the current through the circuit. Here we have a function generator with a voltage described by 8 sine 100t. It is connected in series to a 5 ohm resistor, a capacitor with a capacitance of 0.2 microfarads, and an inductor of 10 henries. It will be useful in this example to remember that the impedance of a capacitor is equal to 1 on omega C times its complex operator, and the impedance of an inductor is equal to L times omega and its complex operator. By applying KVL to this circuit, we find that 0 must equal the supply voltage E minus the voltage drop over the resistor minus the voltage of the capacitor minus the inductor voltage. By subbing in the values for resistance and impedance, this equation can now read 0 equals E minus IR minus I times the capacitor impedance minus I times the inductor impedance. Now we can rearrange this equation for I, and by subbing in our known values 8 volts divided by 5 ohms plus the capacitor impedance J times 1 on 100 times 0.2 microfarads plus the inductor capacitance J times 100 by 10 henries. We find the total current has an absolute value of 0.163 milliamps and an argument of 90 degrees. This can also be expressed in rectangular form as 0.163 J. Thank you for watching my video. I really hope it helped you learn a thing or two about KVL in AC circuits.